Welcome everyone to BTT 151 Fundamentals of Electricity. I'd like to go over your Unit 10 concepts. This week we're going to take a look at three different types of loads that you would find in either an AC or DC electrical circuit. So the first type of load that we should already be familiar with is called a resistive load. So this is the symbol for a fixed resistor. Units of resistance are ohms, and we're often going to see the small Greek letter omega that represents a resistor. So a resistor in a circuit, we apply a voltage across the ends of the resistor, it sets up current flow, and we dissipate heat. Or as we've seen in our series and parallel circuit calculations, we dissipate power in the resistor. Remember the concept of power supplied is equal to power dissipated. We convert electrical energy into thermal energy or heat. In the case of an AC electrical circuit, when a purely resistive circuit is installed in an AC electrical circuit, the components of voltage and current are in phase. So remember from Ohm's law, the current I is equal to the voltage V divided by the resistance R. The next component we're going to introduce is called an inductor. And here's the symbol for an inductor. Units for inductors are in henries, and you're going to see the capital letter H to represent units of inductors. And what an inductor is basically a coil. We talked a little bit about magnetism, this idea that whenever you pass current through a conductor, we basically generate what's called magnetic flux or magnetism about a conductor. Well, if you have a straight piece of copper wire, for example, and we now coil it up, we concentrate that magnetism into one location. Well, inductors behave very differently in an AC electrical circuit. They exhibit another form of opposition to current flow that we call reactance. And specifically, inductive reactance, X sub L, is equal to 2 pi multiplied by the frequency multiplied by the value of the inductor. So what this tells us, in this example, current I is equal to voltage V divided by that value of inductive reactance. So in effect, if I increase the frequency applied to an inductor, it increases the inductive reactance and decreases the current. So in effect, we raise the frequency, we're going to lower the current in a circuit. The third type of component is called a capacitor, and the formal definition of a capacitor, two parallel plates that are separated by an insulating material we call a dielectric. So here is the electrical symbol for a capacitor, and units for capacitance are in farads, and you're often going to see the capital letter F to designate units of capacitance. Well, just like the case of an inductor, a capacitor also exhibits reactance. Specifically now we call this capacitive reactance, indicated by X sub C. So X sub C is equal to 1 divided by 2 pi multiplied by the frequency multiplied by the value of capacitance. And again, if we use Ohm's law to solve for current, current I is equal to voltage V divided by the capacitive reactance X sub C. But an interesting change. In this example with a capacitor, when I increase frequency, I decrease the value of capacitive reactance, which in turn increases the current. So in effect, if I increase the frequency, I increase the current. If I decrease the frequency, I decrease the current. As compared to the example of the inductor, where we increase frequency, we decrease current. If we decrease frequency, we increase current. So inductors and capacitors behave very, very differently. Also like to point out, I had mentioned in the case of a resistor, the components of voltage and current are in phase with each other in an AC electrical system. In the case of an inductor, no longer true. The components of current and voltage are out of phase with each other by 90 electrical degrees. So in effect, the current lags the voltage by 90 electrical degrees. In the case of a capacitor, just the opposite effect. The current and voltage are no longer in phase. This time the current leads the voltage by 90 electrical degrees. All right, so please take a look at Unit 10 in your text, review the PowerPoint presentation, and have a great week.